So probably. Alaikum assalam. Yes. So hayakullah. So I was answering a question. I will reopen the chance to ask more. So basically, by showing calculation, you will see, this inverter at this link cannot power your laptop. You need to find alternative.
دكتور علي عندي سؤال.
Yes, بس خليني أجاوب زملائك and I will come back to you. Okay.
Okay, دكتور إن شاء
الله. So this was the question. So the rest is, it's clear here in the manual. You have questions. Let's take مثلا the first one. So you need to show your data. This is basically, of course, here you need to show this data. Okay, I underlined all of these steps that require answers in your report. Okay, so calculate, of course, you need to calculate these. Paste a link, you need to do a slight, simple research online for a power supply that satisfies this power requirement. Experimental, we did this by video, so nothing to be done here except from your side is to analyze the results and compare with the simulation by filling these calculations, finding the error, and what else do we have? Same here, compare and find error. Okay, what else? Similar here. The rest you calculate the powers, and at the end there is these questions. Find the equivalent resistance. So anybody find difficulty in finding these equivalent resistances?
Doctor, the first one I did it easily, but the second one I am not sure about what I did is right or wrong, because I did the voltage over the current, the voltage measured over the current measured. This will be the resistor measured in one. Am I right?
Yes. Yes, correct. Very correct.
Okay. Yes. So I will replace it the R1 with the same equation, R equivalent 1 and R equivalent 2, but R1 and R2 R3 will change.
لا، هي الميثود خليني اشرح لكم عن نوت. خلينا نفتح نوت اشرح لك الفكرة سهلة جدا و the idea is easy and effective. I'll show you why. Okay, خلينا نفتح one note like this. شباب, are you able to see these notes ولا؟
Yes. قصدك في هذا.
Yes.
Teams.
Very useful.
Yeah. So this is nice. Okay, good to hear that. Okay, خلينا نضيف نوت على لاب 6 آخر لاب. شو نعمل هون؟ خليني أفتحها بالديسكتوب آب. شو صار بالفيديو؟ still rendering. طيب خلي نرجع لهون نضيف a new page. We'll call it equivalent resistance like this. Okay, this means I need to write, so let's go there. Okay, so in general our circuit was this. Okay, we had R1 like this, R2 and R3. Theoretically, how to find the equivalent resistance, which is
R1 plus R2 R3 over R2 plus R3.
Yes, so you see R equivalent from here, like this. Tamam? Now from here to the right, it can be anything. Generally it can be anything: a motor, a lamp, a heater, a combination, whatever. Okay, so here I know these devices, or I know these components, so I can do it analytically. We say analytically like this. شو يعني analytically? Okay, شباب, you know an analytical method. It means using basic laws خلاص. basic theoretical laws. تمام. Here it's equivalent resistance. فهي I will say like this: R equivalent equals what? R1 plus R2 parallel with R3. Okay شباب, you agree?
agree دكتور.
فخلاص 220 plus شو صار عندي 220 plus دائما البارالل الضرب على المجموع. تمام. ف R2 R3 over خلنا نضبط شوي الكتابة over the sum. كشاب and you continue with this. راح يطلع عندك some value like this. طيب all of this is analytical. طيب on the other side you have experimental. The concept from the experimental is that you have whatever, you have something. Okay, device. Okay, and this device is actually operating at voltage I, voltage input, and consuming a current like this I input. Okay شباب, طبعا if these are static يعني they are not function of time, there is no time here, so they are constant all the time. This means I can find an equivalent resistance that is constant as well. تمام. So experimentally خلينا نضبط هون نحط لون ثاني. Experimentally like this you have some R equivalent. Okay شباب. So this R equivalent is what? It's just the input voltage over the input current. And that's it. This is measured. This is measured. And this is measured. And you'll find an experimental equivalent resistance to your device. Whether it is a resistor, transistor, diode, motor, complex circuit, whatever. Okay.
Doctor?
Yes.
It will be the same if we find each resistor and the measured voltage and measured current for each resistor, and do the same as we did in the previous equation, which is R1 plus R2 parallel with R3.
Yeah, you mean finding R1 equivalent, yeah, like this, R1 equivalent, R2 equivalent, R3 equivalent.
Exactly.
And then do the equation. Yeah, it's supposed to be the same. Okay. It's supposed to be the same, but if you have errors in these currents and voltages, measurement errors from your device or from whatever source of error, it will show up. Okay.
Okay. Doctor, I have one question.
Yes.
Regarding the power. Doctor, there
Yes.
are two equations for the power. I square R and
Yes.
VI. I
Yes.
square R and the VI. Doctor, when I did use both equations in the measured power for the measured resistor and the measured current and the measured voltage, there are error, but it's very small error. Like it was 1.53, and the second one is 1.59, 1.56, 1.57, like this.
Yes.
Like this is so.
This is acceptable. Yeah.
Which acceptable? Okay.
Yeah. أنت عملت مثلا R1. You said like this, okay? You said power 1 الطريقة الأولى اللي هي resistor 1 I squared I squared R. R1 measured. This is measured and yeah. So let's do like this. I1 measured squared times R1 measured like this. صح؟
بالضبط.
وقارنت خلينا نسميها measured قارنت
أنا ما قارنت صراحة، بس أنا شفت يعني الفويس شفتهم مختلفين. أنا كان كفضول استعملت القانون الثاني، يعني شفتهم
Yeah.
مختلفين صدمت.
لا القانون الثاني أنت said v squared over r
لا دكتور،
like this.
في اي، لا سوري،
vi
شو الثاني؟ في
v1
اي هي صح
measured times i1 measured صح؟
بالضبط.
لا you are not supposed to have a big error.
الدكتور انا قلت لك مش بيج ايرور بينهم، يعني واحدة مثلا كانت 1.53 والثانية كانت 1.56 ولا 5.
Yeah, this is interesting what you did. بس خليني أعطيك like a hint on this. Now V1 measured, you measured it صح using voltmeter, and you measured I1 measured, right? And at the same time we measured R1 measured. Okay.
بالضبط.
فعليا R1 measured كيف تنحسب؟ In the device internally your in this case ohm meter شو بيعمل الاوم meter? What does it do inside? It measures V1 and measures I1, and internally it will show you R equals V على I. تمام. Based on this if you calculate power from here or from here it should be the same. Okay. The only thing you can say, the only thing you can say, no, there is an error either in measuring R or in measuring one of these or both of them. Okay, but the reality, they should be the same. Okay, the only difference is due to our device.
وياك دكتور صح، لكن الحين إذا استعملنا أي وحدة يعني بيكون جواب صحيح.
Yeah, the answer is fine. To me, the answer is fine. It's just to find, just to practice finding the power of a device.
Power.
Okay. مثلا Pn, already you have In and Vn, so you say Pn equals I1 times V1. PR1, okay, what do I have? R and sorry كان عندي مشكلة feedback loop ما أعرف شو يعني. P1 you can say I squared R I1 R1 like this. Okay, طبعا measured I and measured R. Okay. So to me it's fine if you say V squared over R, it's fine. If you find the difference between these two, you can show them as an extra thing. And
extra things ولا extra bonus؟ في فرق دكتور thing bonus.
I could give you bonus but I did not announce this. فthe rest زملائك الثانيين يمكن they didn't know about this.
خلاص.
بس it's a good comparison to see. Okay. Alright. Okay, so this is this. Now I hope this is clear. My objective of all of this is that you can find an equivalent resistance of a device regardless of what is inside it. This is the point of this experimental approach. Okay, and it is used if I have a motor. ما بدنا نتوسعش بالموضوع كتير. If you have a motor, this is a motor, and you have two wires in the motor. So this is brushed DC motor, and we want to find R internal. Okay. This is one good method to find the internal resistance of the motor, which is the resistance of the coil inside the motor. Okay. by applying a known voltage and measuring the current. Then V over I is your R. Okay. Especially if you cannot disconnect the device, you cannot. It's already operating, and you cannot disconnect it. Then this is a very nice method. Okay, Shabab. So this is this. Any more question?
Yes, doctor.
Yes, go ahead.
Doctor, can you go back to the previous question above? I think on page the one about the picture.
The one about the picture.
About if it can charge the laptop.
أول واحد. This one.
Yes, doctor. What I did, I wanted to achieve the power are almost the same. Okay.
Yes.
So I took the input, صح? We don't take the output.
The input of this transformer?
Power supply, because the power supply, it will provide to the laptop, صح?
Yes. So you consider the input to the transformer, which is?
So I took 100 times 1.5.
Yes, exactly.
But I got 150 watts.
لا مش 100. We assume that we are working with what? 240.
Why did we assume 240?
Because it's common. يعني here in the UAE we use 240.
Oh, okay.
And this is like the maximum power that this transformer will ask for. يعني the power based on this is what? 240 times 1.5. فالشيء نص ال 240 120 360 يعطيك.
Yes.
360 watt. This is the maximum this transformer will require. Now
okay.
my inverter should be able to give that at least or more.
زين يعني if the inverter gave me 150 watt, it will not work?
It will not work, no. In general, يعني it may work if you plug your laptop, but if your laptop is highly loaded, you have speaker, graphics, lighting, processing.
Yes.
It may ask or reach this maximum power demand. Then your inverter may go down, blow a fuse or power off. But basically something wrong will happen. It will not work. Okay, and this is valid for all loads. You have to find the maximum possible load or maximum possible power your load will require and satisfy at least that demand, you know. Okay, perfect. I hope these are clear. The ideas are clear. Okay, Shahab, so more questions on that? I don't have problem. If you have any question, we can spend time on that. The point is that you understand all these details. Okay, so feel free to ask, Shahab. Okay. So this is about lab 6. تمام خلي هذا شوي. It's working. And I'm done. Let's see. Yeah, we can see these notes here. Yeah, okay.
دكتور.
Yes.
هذه آخر سؤال. هذا يسمونه الار equivalent أنت قلت اللي طلعها في البارت الثاني.
Yes.
قلت ال VN على ال I. هل هي نفس ال VN ال V1؟
Yeah, VN is V1 based on the circuit. خلينا نشوف here. Where is Lab7? نرجع. About here. My laptop is slow because I'm preparing a video, so it's. I think.
will I هي نفسها ال I1?
Yes. Yeah, let me double check on that. There's Lab6. Yeah, based on the circuit, Come on, yeah, there's the circuit. Okay, so Vn is here, same as V1. Now I used V1 because it's node number 1, so I wanted to stick with the numbering on these nodes. So yeah.
مش 5 فولت المجر.
لا Vn theoretical 5 volt. المجر
4.995.
Yes, so what you mean is should you use measure? Yeah.
بنستخدم نحن المجرز الفولتج.
Yes, it's better if you use measured. لأن theoretical it's راح يعطيك زي كأنك حسبت الريزستورز سيريز وبارالل.
أصلاً أعطاني دكتور سؤال قال بعد إنه نستخدم المجر.
This one you mean, right?
دكتور قال لي أرسم شيء اللي بالضبط هذا بالضبط.
This one. So this said directly measured using measured V1 and I1.
Okay, دكتور. واضح. تسلم.
So yeah, and it says here this is a black box method, measuring voltage and current to any component. Okay, you can find its equivalent resistance, even if it's not a resistor, whatever it is. Okay, and this is what's really happening inside ohm meters. They apply voltage and they measure the current and they do the division inside. Okay, what about this question, Shah? Anybody try to answer it? This one?
Yes.
Yes, anybody found an answer?
Yes, I did find an answer.
Okay, so this is it. Okay, so I'll leave this to you, but the idea is when the car window, you know, you have a car window like this, and when you close the window, what's happening? Okay, when the window reaches the limit here, you will have, like, if this is the motor of your window, the actuator, basically there is a DC motor inside. Okay, suddenly you will have, okay, if this is the current of the motor, I will be like this, and suddenly it will jump to a high value, simply because the window has reached the limit, and there is like jamming on the motor. So the controller on this, there is actually a controller for window mechanism. It will detect this spike in the current, and automatically it will disconnect the voltage from the motor. Okay, I think I answered the question. All right. Okay, they call it, there's when we see DC motors, we will I will show you how that is done. They call it current measurement resistor. There's a very small resistor to measure the current applied to the DC motor. Okay, we'll come back to this in the DC motor lab. Okay, perfect. Tamam, the assignment is good and concepts are good. Video for the previous lab, I can see it here, but I only can download. I don't know why. It says recording failed to upload. So I don't know if you see the same thing.
Yes, doctor, we have to download it in order to watch it.
Yes, so you cannot stream, you have to download directly. Yeah, I don't know why.
Even the lower link we cannot open.
Sorry?
Even the lower link, the link after it.
This one?
لو اللي تحته.
There's no
the
link.
message after it.
Yeah, sure.
No, on the October 29.
You mean this one?
Yeah.
You cannot stream, huh?
No, I cannot open it.
I think this is Tuesday record. That one succeeded. خلينا نشوف والله شو صار.
It says you don't have access. Don't know what.
Because it's privilege only to Tuesday students. You know what? خليني what I will do is I will give access to your section as well in case you need. I think now probably you don't need it anymore. Sorry, yeah, I think I added your section as well, so I have other section. Yeah, if you try now, it should work. Okay. So because by default only the section under that team will be able to see, unless I add manually like this. So I had to do this manual addition. Okay, شباب. So this is this. شو كمان في عنا? This wraps up lab number 6. Now today we have lab number 7. الحين صار في change before we begin the lab. I think this change is to your benefit, so let's announce that here. Type. Now previously we have discussed the schedule of the lab. Now what we had before is slightly different from this updated version. The news is that you have a project. Previously we have said we have only one quiz and that replaces the project. This was actually my plan to do, but this could not work. Okay, this change is really hard to do like this. Okay, reasons are beyond my reach. This lab syllabus have to continue like this. Okay, because project is part of mechatronics lab. So project is there. Now the good news is the quiz, which will be this week, this is our quiz, is now only 10%, and labs 1 to 4, they used to be 0.7, now they are 0.75 of load. Most of you have good grades in these labs, so basically this will raise your final average. Okay. The quiz has to stay there, so this is this week. Okay, and previously we had sensors 1 and sensors 2. We have 2 labs on sensors. We had 1 and 2, and we had DC motor 1 and DC motor 2. Now this was cancelled, so we'll have only 1 lab on sensors, which is today's lab, and 1 lab on DC motors. Okay, so basically we are left with 2 labs to finish, and the rest we will. Yes.
Yeah, is this project a replacement for the lecture project? We will have 2 projects يعني in mechatronics.
لا, now I discussed with Dr. Irfan, and you have 1 project. This is the plan, unless he tells you something else, which I don't. Probably he will not tell you something else. Okay, so project is 1. So you have the lab part is this one. You have 20% of lab grade. Tamam. What you'll give me here in this is simulation VI. You will discuss about projects when we come here. This lab here is just getting started, and we will discuss how you can get started with the project. Okay, so basically this is simulation. Now in the lecture part, I think Dr. Alfan asked you for either a report, maybe presentation, maybe both. Okay, so I'm not sure about how will Dr. Alfan discuss. Now this has its own weight, like percentage of lecture. Okay guys, so it's 1 project, 2 folds, practical, which is lab here, and theoretical, like report for the lecture part. Okay, شباب? So only 1 project.
دكتور الوقت جدا ضيق دكتور.
yeah we'll consider this
يعني بس باقي الشهر على الفاينالات. فنحن يعني عندنا الاس دي بي وفوق هذا عندنا المترمات والكوزات، والحين صدمه جديده البروجكت. يلا خبرك عاد متى بنخلص دكتور؟
well I agree with you.
فيعني هذا فوق طاقتنا دكتور. يعني لو كنا في الجامعه كنا نقدر نقول يعني قبل يعني يعني الفاينالات كانت نهايه الشهر او نصف الشهر 12، الحين صارت بدايه الشهر 12. يعني الوقت جدا ضيق دكتور، يا نذاكر حق الفاينالات يا نسوي البروجكتات يا نركز على الاس دي بي. فما نعرف صراحه ايش نسوي بالضبط. دكتور يعني خليك في مكاننا وحس فينا بعد وشوف.
yeah I did that. زايد صح؟
زايد.
Yeah, I did this, Zaid. I thought with you, and I told you I wanted to cancel the project, and this was the initial plan.
بروجكتات منو اللي مسوي البروجكت هذا؟
So basically the project is part of the lab. هاي البلان. خليك معي زايد. البلان الأساسي البروجكت is part of the lab. Because we cannot do a practical project, we said let's convert this into a quiz. Now, converting this into a quiz, we have changed the nature of the lab. Now, from my side, I cannot do a simple decision about this. Okay, it has to go through the committee. There is academic committee. They will discuss. It will take months to agree, and it's complex to do such a change. So such a change I couldn't do, and this was brought to my attention by Dr. Arfan.
زين نقدر نكلم الهيد بخصوص الشيء هذا؟
نقدر نكلمه دكتور فعلا، لأن يعني هاي فوق طاقتنا. يعني يا ان ما نسوي بروجكت، يا ان يعني الكوز انا اشوف كان افضل بكثير من البروجكت. يعني فجأة دكتور انت يعني الحين تقولنا عندنا بروجكت يعني بسم الله.
شو الفرق؟
الفرق انه دكتور يعني الضغط مش طبيعي دكتور. يعني الجامعة صدمتنا بايميل انه يلا بداية شهر 12 عندكم فاينالات، فنحن ما نعرف الوقت جدا ضيق. الحين الاسبوع الجاي عندنا تسليم اس دي بي، وعندنا ميدتيرم برزنتيشن، فنجهز حق هذا ولا نجهز حق هذا، وللحين ما خلصنا الميدتيرمات دكتور ولا خلصنا الكوزات. باقي عندي 3 ميدتيرمات انا ما خلصتهم بعدني. فكلهم يعني حتى الدكاتره مصدومين، فكلهم قاعدين يسرعون الواجبات الكوزات كلهم قاعدين يضغطون علينا. فالحين هذا الضغط الجديد ان البروجكت يلا.
لا اول شيء انا معك بهالخصوص، بس البروجكت ما راح يكون شيء صعب. يعني اذا اعطيتك مثلا ماس سبرينج دامبر او بندلم لايك ذس كان يسميه بندلم.
صح دكتور، انت ممكن تسهل علينا بحيث انه يعني يكون شوي المطلوب من المشروع اسهل.
انا ما راح I will not increase load on you because I know how
افضل دكتور. حتى يعني لو في بروجكت دكتور تخف علينا شويه، لان تعرف حالتنا دكتور. يعني
انا بعد افضل نكلمهم ونبا وكذا. هاي الطريقه اسهل.
What do you think? We cancel the whole thing like this? Something else will replace it.
انتم بروجكت زين، لكن بروجكتات يعني انا ما بقول لك خلينا نسهله، انت خلهم باللي تشوفه معقول يعني مراعاه الظروف.
هو احنا اللي صار صحيح تغيير، بس انا I told you I will try to make it to your benefit. فاول benefit كان زدنا الويت على اللابات هذا، فعلاماتكم اكيد راح تتحسن. This is number 1. قللنا الويت على الكويز. تمام. So this is number 2. Number 3, I will not give you a hard project because the project is 2%. شو يعني؟ زي كأنه 2 labs. Basically project 1, 2, 3 are equivalent to 2 labs only.
أنا 30%.
لا 2%. 20.
يعني 30 in total. اوكي 20 اوكي
20. ما هو 10 the weight is 10 here. If you sum all of these, the weight is 10. This is 2 out of 10. So basically البروجكت زي كأنك عامل 2 labs only. فاحنا خلينا 3 weeks على 2 labs. تمام. فهي أول ثالث تسهيل. التسهيل الرابع إنه لا I will give you a project that is fit to be done within these 2 weeks like this. Last week
يعني دكتور بس سبمشن ولا لازم نسوي برزنتيشن بعد نراويك انه كيف سويناها؟
لا I think you have to check with Dr. Arfan. Probably he will ask for a report. Simple
ريبورت
report.
عن اللاب اللي سويناه.
عن
البروجكت
البروجكت نفسه. أعطيك مثال. خليني insert. طبعا the project I will give you topics. I'll give you topics.
ونحن نختار.
Yeah, implement it with Lab7. زي كأنك عامل two assignments. That's it. خليني أعطيك examples. Okay, بدنا page جديدة like this. كيف ندخل؟ Yeah, an example is this here two tank system. خلينا نرسم لك إياه. I wanted to discuss with you later on, بس يلا okay. Take this example. You have one tank and you have another one. Okay, you have water here and you have level of water here. You have flow QN. You have level 1. أعتقد هالexample حليتوه بلاب الكنترول. Lab 2. Level 2. Okay, and you may have here some Q output. Okay, can you simulate this in lab view? Yeah, you should be able to. Okay. فإحنا what I will do, I will give you a set of topics of simulation of systems to simulate like this. Will help you get the model for this one. All what you need is model. I'll get you started with the lab view, and all what you have to do is to continue with your model. Okay. For this is an example on a project. Now, does this overload your time ولا لا؟ I don't think such a project will give you an overload. Another example is let's take this مثلا this pendulum. Okay, if you have a pendulum and you have a force like this, and you know you have an angle theta. Okay, then we want to simulate actually theta of t, and if you have force here, you just create a VI that shows the variation of this theta of t. Okay, another example is you have a mass spring damper system. أكيد بتعرفوا هالسيستم شو كلها. You have mass 1, mass 2. You have a spring like this. You have a damper. You have a spring. You have a damper. Yeah, let's take it like this. Okay. And you have maybe x1. Yeah, you know, this is just like this. And you have x2. How hard it is to plot x1 like this and x2 like this given some initial conditions. I don't think this is really hard. Okay.
واضح دكتور.
Yes, so this is the project. It's very, very simple, nothing practical. It's just simulation of something you know already. Fluid system, mechanical system like this. Something simple. Okay. The idea is how to translate this into LabVIEW code. Okay, شباب. So from my side, للأسف I cannot decide whether to cancel this. But if you want to cancel the project or you find it too difficult to do, I think you can write Dr. Arfan and then he can discuss another solution for this one. Okay, شباب. واضح الموضوع شباب بالنسبة لكم؟
واضح نعم أستاذ علي.
Okay. This is this. Okay, can we begin today's lab ولا؟ خلي بس نضبط هاي. Yeah, this is that. Okay, so today And today we will simplify. It's about sensors. I'll explain to you some theory and do part of the experiment by video, and the other part I will upload soon. It's still being prepared, but I will upload soon to YouTube. So watching the video and taking the data from the video is directly straightforward. Okay, and same as previous lab, you will have a template you have to fill and answer questions. Okay, so this is this. خلينا نفتح المانيوال. Now where is my manual? Let's get that. No, not here. I don't think the manual is available in Moodle, so what I will do, I'll put it here on Teams. Okay, so later on I will upload it to e-learning as well. Okay, mechatronics sensors. Kajab, can you see the manual in the files tab?
Yes, المانيوال طالع PDF.
Okay. All right. So now today is about sensors, mechatronics, sensors. Okay. Now sensors are very, very easy and straightforward to use, especially these days. You have integrated sensors. Okay. Now we'll see what this means in a moment. We will identify two techniques today, which are the principle of resolution and calibration. Okay, so we'll see two types of sensors. Okay, different types, basically two types of sensors. We'll measure angular position. Basically, we'll begin by sonar. We'll investigate sonar as a long-range distance sensor, in addition to potentiometers and encoders as angular position sensors. Okay, so two types of sensors today. So when we have a lot of types of sensors, we have seen, we have given examples on some of them previously. Okay. What sensors should be used to measure strain? Did you address this in the lecture part? Okay, so for that use strain gauge. So again, did you learn about this in the lecture part or not yet? Strain and strain gauges.
I don't think we did, as far as I remember. Yeah.
All right. So this means, yeah, it's good to know your feedback. حتى نعرف. Yeah. So you did not yet. So I don't know if you will address this or not, but it's good to know there is something called strain gauge. It's very simple. For example, what do we use to measure distance? Okay, I will give an example that we all know. Basically, this is the sonar sensor. Okay. Now we all have. خليني أفرجيكم صورة لهالشيء. Where do we have sonar sensors? Okay, these are breakout boards. بس خليني أفرجيكم example that we all encounter daily. Okay. What is this? We know that most cars these days, they have parking assistant, right? So they use, basically they use a distance sensor in order to sense surrounding objects. Okay. Now, if you look to the car bumper from front or from back, you have these dimples. Okay, I'm trying to find a clear image. Yeah, this one. So most of us see these dimples. So let's copy image and go to OneNote. Yes, sonar and ultrasonic, it's the same. اوكي خليني افتح الون نوت ونبلش نكتب. This is slow a little bit, but fine. Alright, so I'll make it lab number 7. Lab 7, let's call it now here, this one here is we all see this in our car bumpers. This is actually a sonar or ultrasonic. We call it sonar or ultrasonic sensor. Okay, right. So in cars, you know, these are used to sense surrounding objects and to avoid obstacles, and in car in parking assistance as well. Okay, so how do they work? We'll see in a moment. Okay, so this is an example on what you call position, or let's call it distance, not position, distance sensor. Okay, it measures the distance from a reference to an object. Okay, so this is part number 1. Okay, the sonar sensor. Now it's called a long range distance sensor. We'll see why experimentally. Alright, so other types I hope we have the time to experiment with today. In case we don't have the time, I will record a video about them and upload it to YouTube. Okay, so potentiometers and encoders. Now both of these sensors can be used as angular position sensors. Okay, I've seen an example on the sonar, but what about this angular position sensor? Anybody can give an example on this angular position sensor, or like a practical example where we need to measure angular position? Okay, anyone can provide an example?
Rotation of anything, يعني. I can't think of something now, but يعني, where there is rotational motion, we need an angular.
Exactly. So this is a very generic answer. Okay. Now, whenever you want to measure, if you have a shaft like this is a shaft. It can be a motor shaft. مثلا here you have a motor like this. خلينا نرسمه بشكل أفضل. And you have a motor shaft. Okay. Now, in many motors, you will have here an attachment or like extra device, and this device is used to measure theta, where theta basically is the angular position of your motor. Okay, sure. Now this motor, it can drive anything. So if it is like screw drive, imagine that this has a thread like a screw, and here you have a body, and the body is internally threaded. Okay, sure. So like this. Now, you know, this theta or angular rotation will be translated into linear motion. شباب, you follow? Okay, and this can be what, like 3D printer. It can be مثلا CNC. We call them motion stage or motion actuator. CNC motion stage. You have what else? A wheel of a robot. If you have a robot like this, let's say you have wheeled robot, you have wheel, you have wheel, you have another wheel like this, and you have another wheel like that. Okay, now you want to measure theta 1, theta 2, theta 3, or theta 4 like this, or maybe all of them. Now here you have a shaft, and you should connect an angular position sensor.
I think this also extends to cars, صح? Measuring the speed miles of a car. It's measured using an angular sensor, which measures the rotation of the wheel.
Using yes, exactly. Thank you. Basically, in cars, where do you find this? I don't know if you are like mechanical, you like mechanical work, but if you decide to dismantle a car wheel, you will see, let's say, wheel sensor. The wheel is very generic. Yeah. So you can see here we have a hub. This is a car hub. Now inside the car hub, eventually, if you look carefully, you'll see there is a wire connected to your wheel. This wire is connected to a sensor, and this sensor is basically measuring either the angular position, or because if we measure the angular position, simply we can calculate the speed, the rotational speed of your shaft. Okay, so why do we need to measure, for example, in cars, why do we need to measure the speed of each wheel? Anybody has an idea?
عشان if they are not balanced or something.
Okay, this is one aspect, but more importantly, because of anybody heard about VSC?
No, I have no idea what this is صراحة.
يمكن الشباب اللي بيحبوا يعملوا دريفت لازم يكونوا يعرفوا ال VSC. Now VSC is vehicle stability control. What happens is you have the car, so let me draw it again. You have 4 wheels, right? Now this system basically will measure the speed of each wheel. Okay, let's call it مثلا I don't know, any symbol, V1, V2, V3 and V4. Now by measuring all of these speeds, the speeds of each wheel, you can simply know, طبعا of course you need to measure the steering wheel angle using another encoder. Okay, this is another example where you we'll use an encoder. By comparing theta V1, V2, V3 and V4, the computer in the car can estimate if the car is going to skid or not. Okay, you all know, skidding. Okay, basically when for example you steer the car this way, but instead it goes straight or another way. Okay, due to slippage, you can say slippage. Okay, the computer, there's a computer or dedicated system for this VSC system inside the car. It has 4 encoders. On each wheel you have an encoder. The encoder will, consequently in the computer, you will measure speed from the encoder. And if for example, you steer the car forward like this. Okay, you know the theta is 0, so you steer the car forward. In this case, V1 should be equal to V2, should be equal to V3, and should be equal to V4. But for some reason, مثلا V1 is greater than V2. What does it mean? It means that this speed here is greater than this speed. Oh, but you are steering the car forward, and since this speed is greater than this speed, it means the car will simply roll or skid this way. Automatically the computer will apply some braking through ABS to this side in order to counteract this action here. Okay, this is like these were examples from automotive industry. So you have a lot of examples where you need to measure angular position. This is my main point, is the angular position. Okay, we mentioned an example here, which is the car wheel. There's a sensor in this assembly that measures the steering angle, and this is how, for example, when you are reversing in your camera, you'll see these guidelines that show you the path of the car. It's through the measurement of this angular position. Okay, this is again another generic example of yes.
I have a question.
Please.
Why V1 can be greater than V2? Both wheels are not driven by the same axle?
Okay, imagine this scenario.
Okay.
Let me show you an example. Okay, you have, خلينا أنظف شوي هون. محينا كل شيء. Let's bring it back like this. Okay, imagine you applied some braking action, and here on the floor on this side you have some oil or some ice or some water, but here you have dry ground. The ground is dry like this. Okay, now if you apply some brakes, what will happen? At this side here, the friction is very, very small, but here the wheel is tightly gripping the ground. So what will happen? The car will try to skid this way, but you as a driver, you are steering this way. Automatically the computer will brake these wheels here and here in order to counteract this skidding or slipping situation. Okay, another example, your car is like this. I didn't recommend you try it unless you are professional. Not very professional, but okay. If your car is, let's see, say you have rear wheel drive like this, and I think most of us have tried this at some point. You are steering this way. If you apply very high torque, شو بصير? Torque is very high. What's going to happen? Simply your car will start drifting. صح؟ معي شباب ولا؟
Yes.
Makes sense.
This is how drifting racers will do. They will actually disable the VSC system. You see, so here we have check VSC. Sometimes if you have this check VSC in your car, this is very dangerous. You have to check VSC, because for any reason, if you, for example, suddenly steer your steering wheel to the right or to the left, the car may skid or try to hit the curb, etc. So you'll have very dangerous situation. Okay, because the stability system is disabled.
الVSC غير التراكشن system, traction control system.
Yes, the VSC شو difference بيناتهم? I will show you. The traction, it will monitor the theta, the speed of the car, and compare it with. Okay, let's put another color here. Okay, Give me orange. Okay, so this is the speed of the car. Speed the car. So you know the speed of the car is some number speed. Consequently, the speed of each wheel can be calculated. For example, the speed of this goes very, very high. Okay, and the car is not rotating, and it's not moving forward as it's supposed to be. This means شو صار عندك؟ تفحيط صح؟ So the anti شو سمينا مش الفي اس سي، شو الثاني سمينا؟
traction system.
Yeah, the traction will be sure that the wheel here is not moving. ما بصير عندك تفحيط. It's not ما عماله بفحط العجل like this. Okay, فبتشوف the speed of these wheels, it shouldn't be different from the speed of the car. While the VSC will monitor what we call the yaw rate. This one here is called yaw rate. There's actually something called raw sensor inside the car. What's the yaw? You all know the yaw, صح?
Yeah, will steering left to right.
Yeah, the yaw rate is the rotational rate of the overall car. عارف رسمة صارت معجوقة شوي، خلينا نحطها برسمة ثانية. The yaw rate is the rotational speed of the car like this. Let's call it phi dot. And there's a specific sensor for this. It's called yaw rate sensor. This is the VSC. This is what's different from traction, is that the VSC will monitor the speed as well as the steering angle theta of your steering wheel, and this phi dot here. Based on calculating all of these variables, it can determine if you have vehicle instability or not. If you have slippage, not slippage, skidding. The term is skidding. Okay, skidding again is steering one way and moving another way, like this. Okay, so the stability will ensure that the direction of the car, this is as close as possible to the steering angle by applying some ABS brake or ABS signal to specific wheel, like this. If you break these, the car will move actually in the opposite direction. Okay, so basically, if you break these, the car will try to move the opposite direction like this. Okay. All right. I'll give you a link on VSC, and if you are interested, you can see its importance. Yeah, this is a nice video here. You see the situation? You suddenly try to steer to the left, and the ground beneath the car may be slippery. Okay. So this is the skidding situation. Okay, I'll give you the link. You can watch it at your own time, شباب. لما تفرعنا شوي من الموضوع. Okay, so this is the VSC. All right. Now, again, probably I will not have time to address the angular position, potentiometer and encoder. So again, I will record them in a video in case we did not finish. Okay, so today we'll focus into a sonar sensor. Okay, شباب. So what is sonar? Sonar is very, very simple sensor. Here I can see a type of a circuit. Okay, actually this is a sonar. Okay, this is the source. And here I can see this is an integrated circuit that does all the conditioning. Okay. The physical principle is very easy. Here you have the ultrasonic transmitter and receiver. The ultrasonic will generate an ultrasonic acoustic wave. Okay, شو يعني شباب ultrasonic acoustic? So these waves are ultrasonic. What does it mean, ultrasonic? تسمعوني شباب ولا الصوت اختفى؟ لا, still there.
I think it relates to waves of certain frequency or something. ولا؟
Yes, waves of acoustic. شو يعني? Sound wave.
Audible, okay.
Yeah, so basically you have sound wave. طبعا مهم الحين راح نشوف limitation on this. This is sound wave. شو يعني؟ Sound wave requires air in order to move, صح? But the frequency is greater than the audible range. Okay, the audible range is around how much شباب? You know the audible range? اللي هو أكبر frequency that we can hear. Yeah, exactly. Okay, but what's that range, the audible range? Depends on the age, by the way. I don't know if you, let's say 16 kilohertz, something like this. 5 to 20, yeah. But if you are مثلا if you are above 30 years old, you will not hear more than 16 kilo. Okay, younger people can hear about I don't know, up to 19 or 20 kilohertz. Okay, so it depends on the age. Basically, there is research on this one, and this experimental, and it doesn't need theory. So this is this type. The ultrasonic is F. Okay, so F ultra is something around let's say between 25 kilo and I think 50 kilohertz. Okay, so this is this. So this is above the audible range. This is why it's called ultrasonic, because we cannot hear it. Okay, so the sensor will transmit this ultrasonic beam like this. All of these red waves are the ultrasonic, and if there is an object in front of the sensor, like this target here, this ultrasonic wave will be reflected back to the sensor through these blue waves like this. Okay, so this is basically what you call echo. This is the echo of your transmitted wave. Okay, now mathematically here, if I define a distance d by measuring the time it takes, okay, inside the conditioning circuit, there's a timing circuitry that when it transmits the ultrasonic beam, it will start a timer, okay, and when it receives the echo back, it will stop that timer. Okay, this is like an approximation of this operation. Okay, so by measuring the time it takes for the wave to go like this, reflect back from the object and come back, okay, this takes some time t. By measuring this time t, one can estimate the distance between the sensor and the target. Okay, now the shape of this beam is spherical cone ultrasonic pulse. Okay, called pulse or ping. All right, so basically here the idea is the following. If I know the speed of sound, this is the speed of sound, and this depends on the density of the air and temperature of the air, etc. But this can be calibrated all the time. Okay, if you know the speed of air, the speed of sound, this is constant, and t is measured. Simply, a mathematical law is given to me like this: half c times t is your distance. Okay, shabab. So this is the physical principle of the sensor. Now, me as an engineer or as a user, as a developer, let's say, I'm not really interested into the physics of the sensor. Okay, let's write it here. It's good to understand physics of a sensor, but as a developer, doesn't really need to go deep into the physics of the sensor. Okay, what I need is to be able to utilize or to use this sensor in a system. This is my approach as a mechanical engineer. Okay, shabab. Although the physics is very simple, but it's like this. Now, many details here in the manual. We already discussed those. Now, what we'll do, we'll find the limitations of these sonar sensors. Now, we'll find out that these sensors are good for long-range distance measurements. Okay, they are not suitable for low-range or very small variation of motion. They are good for measuring large distances, and the resolution will be limited. Okay, we'll see that experimentally. Okay, we will measure. We'll use the Quasar mechatronics board in order to calibrate and study the behavior of this sensor. In general, I have this information given to me that the one we use here in this board, the Quasar mechatronics board, it can measure objects ranging from 6 to 254 inches. Okay. Although it is hard to verify this, we'll find out that our system here is limited to around 25 inches. Above that, it will not give me any value. Okay. Now, we distinguish two things here. This is the sensor capability, the sensor itself. Okay, sensor only. If you have sensor plus or connected to conditioning circuit, you may have more limitations on the operation of the sensor. Okay, simply because of the amplifier range, because of the internal circuitry, this conditioning part here may limit the given range. So what's given to me here is actually the sensor range, but you'll see that my combined range of sensor plus conditioning is about 25 inches. Okay, we'll verify this through experiment. So this is this. Now here, this is grayed out. It's optional. Okay, it tells you about the conditioning used in this sensor. It's actually using a non-inverting amplifier. Okay, did you study amplifiers in the lecture part? Op amps and amplifiers?
Yeah, I guess we did, yes.
Yeah, so basically it uses a non-inverting amplifier, and this is yeah, so this is basically the circuitry for this non-inverting. It's very simple, and actually you can build this in lab. I hope you do a real project where you can see that these are very easy to build. Okay, you have resistors, and this is just an IC which is available in the market. It's very cheap. Okay, so it's really easy to build the circuit. Now this has been done to me in the sensor itself, so I don't have to worry about this. I just directly take the output from the amplifier. Okay, this is the IC where all of the conditioning is happening. Okay, this IC is conditioning circuit. Okay, all right. Now, what I'll focus on today is the resolution as a concept, and particularly for the sonar sensor, and range. These are the important topics. Okay, you studied these in the lecture part, resolution and range. Okay, we'll define them when we go to the experiment part. Okay, so now this is a very important note here, that sonar sensors are in general not suitable for close range measurement. This is fact number one. Please remember this one. Okay, and their resolution is relatively coarse. شو يعني this one they have bad resolution. Okay, no. And again we'll verify experimentally. I'll define this to you experimentally. Okay, so more limitations. They may not detect soft objects such as clothing, blankets, porous materials. Okay, for example, if I have a metal fence, you know, these used in I don't know, some windows, they have them. This is very, very porous body like this, and it's not good to use ultrasonic to measure the distance to that. Okay. Now another limitation is this one. It's very tricky. Sonar sensors don't work in space. Okay, can anybody tell me why? Why sonar sensors don't work in space?
They need a medium to travel through the waves.
Yeah, exactly. Because in space you don't have air, so basically there is no medium for the acoustic wave to travel. Okay, so this is other limitations and tricks about these sensors. Okay. Okay, Shab. Again, this will follow by video. Now I'll skip all of this about potentiometers. We'll come back to them. Angular encoders. Explain this in a video. Skip that. And I'll go directly to. And we have discussed the angular position measurements, but unfortunately, I don't think we can do it today. So come back to that. Okay, experiment. Okay, Shab, before we go to experiment, any question or note?
Clear.
Clear, perfect. All right, now the experiment. Last time, we have did it live, but the quality was not good. So I have tried to record a video on that. I'll discuss. Let's see. I hope the video is done. Yeah, finally it's done. Okay. We'll discuss the objectives of the experiment while the video is uploading to YouTube. Let me just خلينا نرفع شوي on YouTube. It should be this one here. Alright. This is the video. It's ready. Okay. Oh, where's the net? type. Okay, this is that. Okay, 5 minutes, and we will come back to that video. Okay, now the objective of the experiment is the following. For the sonar, I want to calibrate the output of sonar. Okay, we will discuss this calibration. We'll determine resolution, and basically I can add here range. Okay, resolution and range, and we'll see the capabilities and limitations of these sensors. Okay, it's just to understand how it behaves. Okay, I'll not go to physics and circuitry. These are topics by themselves. Okay. All right. What is calibration? This is very simple technique. Again, these are delayed. Alright, so let's see here calibration. Calibration. Okay. So in calibration, it's very simple. I have here a device, a sensor. Here. And now the sensor has an input. Okay. In case of sonar, what's the input to our sensor? As a variable, as like mathematical variable.
Time.
The input is always the physical variable that I want to measure, which is
distance.
Distance d. And in response, it gives me what? Now I'm considering sensor plus circuitry in this case, plus circuit. The circuit has already amplified, conditioned, filtered, and gave me voltage. Okay, شباب. طبعا not always you have this case. Sometimes you have a frequency instead of voltage. So you have to measure a frequency to estimate your input or to measure your variable. Okay. So here our circuitry has already conditioned the output in terms of voltage. So this voltage is a function of distance like this. طيب. Now next idea is how can I convert, okay, like this, how to convert voltage to distance. Okay. طبعا of course you have in mind that measuring voltage. Okay, let's see here, measuring voltage V, then how to convert this to distance. Now we have seen this topic, how to measure voltage. Okay, شباب, you agree? We have seen how to measure, basically how to measure voltage. In the DAC lab, right? So you need a DAC board or voltmeter or data acquisition system in general, analog digital converter. So I have a voltage ready. Okay, now my task is how to convert it back to distance. Basically this is done through software, and you need to calibrate. Okay, this is my focus today, is how to calibrate. Calibrate شو يعني? By measuring voltage at different distances or generally speaking, different inputs or input values. Okay, which are known a calibration curve, or basically a relation between input and output is obtained. Okay, so what I have here is I need to measure V at different known inputs. So what I will do now, generally speaking, the idea of calibration, I will apply D1, okay, and measure the voltage that results from that distance. Then change it to D2 and measure V2. D3 and measure V3, etc. You do as much points as you need. Okay. Now, if I have samples, these are my samples. Simply, I can build a relation between V and D. Okay, sure, we agree. Alright, now how can I apply D? Okay, this is actually important. You need a reference. Okay. Now, how can I obtain this reference? You either use accurate device or more accurate device, or you use a standard. Okay, so before we go, you understand this idea of sampling? Let's call it input output sampling. Okay, sure. Now again, I'll need here a reference. Okay, this reference, I know the value of D1 because I apply it manually. Either I use a ruler or another more accurate device to measure these D1, D2, D3. Okay, I'll simply place an object in front of the sensor, and for each D I'm going to obtain a different voltage level, and eventually I will get a relation between them. Okay, now I'll speak about the calibration curve and the standard. Okay, since you are here, now what is standard? Now the standard is the definition of the unit. Unit. For example, the kilogram. What's the standard for kilogram? Anybody can answer? Now the standard is actually the it's the standard. It's the body or the object that has been used in order to define this unit. For example,
it's the reference point.
Sorry?
Can we say the reference point of a certain quantity or measurement?
You mean the reference location?
No, I mean the standard. Can we say it's our reference?
Yeah.
For example, in case it's a mass.
Yes, basically you are talking about the reference here, and this is it can be the standard or can be another accurate device. Now we don't have this, and we don't have this actually. We just have, we can say accurate device, but we don't have a standard. Okay. So yes, indeed, the standard is our reference in this case, but when you say that your sensor is calibrated against the standard, this means you have used the original, for example, in case of mass, you have used the original body that has been used to define the kilogram. And you know this for example, definition of kilogram, it's defined, or it used to be defined through the mass of an object that exists in somewhere in Paris, in France, somewhere in one of these museums. Okay, so and this is a physical object. Okay, maybe for general information, let's see that. Okay, the definition of kilogram. All right, so this is here a replica of international prototype of kilogram. Okay, it's Cité des Sciences et Industrie, so featuring. All right, so this is displayed here in this, I think this is an institute or a museum maybe. Yeah, it's a science museum. So this is a replica of the international kilogram, the body that has been used to define the kilogram. Okay, so here I can see that the definition of this unit is attached to a body. People in the world, they have agreed that this kilogram, they have reserved it, they put it in some place and agreed on that unit, and they started to make replica of that body. All of them, they have the same weight, and use them to calibrate weighing balances and other instruments that need this mass. Okay, so basically a reference, a standard reference is the standard or the body that has been agreed on to define the unit. Okay. Now, what's the importance of this this information? The importance is this. Standard calibration. Okay, I'll give you an example. Okay, now this is very important for you as a user, which is called the calibration certificate. If you buy a device or a sensor, basically, you might obtain what you call calibration certificate. Now, in this calibration certificate, they actually give you a table or a curve that basically contains this information. Okay, let the screen move a little bit. Yeah. So whenever they give you calibration data, they give you this table here, and they tell you, did they use a standard in this, or did they use a device, a more accurate device? And if it's a more accurate device, what was the tolerance and error of that device? So in this way, you know that your sensor or your device has been calibrated against a standard. In that case, you trust your device or your sensor. Okay, maybe I can zoom to this. Yeah, for example, here I can see this is what is this? A calibration certificate. This is my calibration certificate, and it says that your reference temperature was 0.02 degrees Celsius. So apparently this is a temperature sensor, at that sense, you had the. So I think this is not a sensor. This is a logger. Okay, so your data logger. Okay, so same technique applies. That your reference temperature here is 0.02, and you obtain the same 0.02, but at minus 15.02 you obtained like 0.01 of error. Okay, so you see here all of your output values, whether from a sensor or from a logger, they have been measured or calibrated against a reference value. Okay, now whenever you see this certificate with your device, you have a more confident about your readings or about your study. Okay, some sensors in the market, especially cheap sensors, they don't provide this calibration certificate, and sometimes it is more expensive than the sensor itself. The certificate can be more expensive simply because you need a reference, which is expensive. You need accurate data, lab research, so the calibration can be really expensive. So whenever you do studies, research, and you need something trustworthy, and you need to be confident about your readings, you need to consider such calibration certificates. Okay, واضح شباب is the technique or the principle, is it clear to you?
Yes, clear, Mr. Ali.
Nice. Now we have a lot of examples about this calibration and calibration certificates, but now the time is limited شوي, so let's skip that. I hope the idea is clear of calibration. Now the next thing is very simple. I'll explain to you the calibration curve. Actually, it's explained in the video. Okay, so let's skip and go directly to the video. I'll give you the link. Okay, let's see that. Already copied the link, but you know. Okay. So the video is 17 minutes. Okay, so I will let you watch it from your side, and we will come back together at what's the time now? 20 minutes at 5:15. Okay, sure. So I'll give you this link here in the chat. Please watch it from your side. It should be, yeah, the HD version is now available, so it should be very clear now. Okay. Okay, so I'll leave you with the video, and we'll come back at 5:15. Okay. Okay, can anyone just confirm if you can see the video?
Yes, I can watch. I can see the video.
All right, perfect. Okay, catch you later.